Yes, welcome to Filo. Am I audible? Please respond. Please respond. Yeah, hello. Okay, fine. Let us move through your question. One second, let me read your question once. You have sampled a population in which you know that the percentage of the homozygous recessive is 36. Using that 36, calculate the following: the frequency of A genotype, the frequency of A allele, the frequency of capital A allele, the frequency of capital A and capital A small a. Okay, fine. See, they are asking about the small a genotype, right? Do you want the explanation or the answer? Could you please tell me? Student, could you please tell me, do you want the explanation or the answer? Okay, fine. As you are not responding, I'm just directly going to my answer. Finding the answer with explanation. Okay, fine. That is fine. See, they have given as the frequency of the genotype AA is 36 percentage. Right. 36 percentage means we can write it as 36 by 100. Right. Right. And see, there is an equation actually. We will be writing as q square is equal to 36 by 100. That is the frequency of this allele we will be writing like this. Okay. There is an equation like you might have known this p square plus 2pq plus q square is equal to 1. That is a plus b the whole square formula. We will be applying this here. Okay, we will be applying this here according to the Hardy-Weinberg law. So what will happen is that you will be getting q square is equal to 36 by 100 and you will be getting q is equal to root of 36 by 100 that you can write as 6 by 10 and that will be equal to 0.6. Okay, this q is actually representing the frequency of recessive allele. So the frequency of recessive allele is 0.6. Do you understand or not? Do you understand? Yes, okay, fine. Let us move on to the next one. The frequency of A genotype is so, yeah, recessive allele is so, this percentage. What percentage? This Q you will be finding and you will be getting a 0.6. Okay, that is the answer for the second one. So the first one's answer they are asking about frequency of AA genotype. See, AA means there two A are there. So you can directly write as 0.36. That is 36 by 100. The second one they are asking about the frequency of A allele. A allele will be 0.6. And the third question, the frequency of the capital A allele. Okay. See, capital A allele they are asking. You should understand that there is another equation according to Hardy-Weinberg law. We will write P plus Q is equal to 1. Okay, P plus Q is equal to 1, where P is the percentage of, or you can write as a frequency of the dominant allele, and Q is the frequency. Yeah, fine. It is zero point 0.4. Okay, so you can write as 0.4. Then the last question, the frequencies of the genotypes A, and the small capital A, small a. Okay, fine. Capital A means it will be equal to P square. P if you are getting as 0 0.4, P square will be 0 0.4 the whole square. That will be 0.16. Okay, capital A is 0.16. So what will be capital A small a? That will be equal to C when we are taking P square plus Q square plus 2PQ. This is the dominant, this is the recessive. This 2PQ will be giving you the capital A small a. Okay, so you should write that 2 into 0.4 into 0. What was the value of Q? 0.6, right? So you will be getting 0.6 into 4, 24 into 48. So you will be getting 0.48. That is the value of the capital A small a. Do you understand? Do you understand, Lauren? Thanks. Yes, I understand. Okay, fine. Any other questions? Any other questions if you want to know? Lauren, yes, I need help. A whole page. Okay, fine. Okay, fine. Let us do this. In pea plant, the flowers can be purple and white. If field of peas, you count 80 plants with white flowers and 142 plants with the purple flowers. Okay, fine. Okay, fine. Let us write it. So see, once again read the question. Every time I need to come to the page back. Yeah, purple is capital P, white is small p. 18 plants with the white flowers, 142 plants purple flowers. 18 is white, 142 is purple. Okay, they are asking us to find out what? What is the value of P? What is the value of Q? What is the frequency of heterozygous plants in the field? Check your work. Okay, fine. So we need to find the value of P. We need to find the value of Q. Everything we need to find. Okay. What is P? What is Q? This is white. This is purple. Okay. Purple is our dominant one. So the frequency of the dominant allele will be the P is actually the purple and the Q is actually the white. First of all, you should identify that. Okay. So how can you apply this here? How can you find the value of this P square? You can say that that will be our, sorry, 142, right? Yeah, P square you can say that that will be our 142. Q square you can say that. Wait a second, wait a second. In a pea plant, the flowers can be purple or white. In a field of peas, you count 18 plants with white flowers and 142 plants with purple flowers. What is the value of Q? What is the value of P? What is the frequency of? Okay, fine. Okay, fine. Anyway, let us try to solve this. So, okay, fine. The number of purple flowers they are giving us 142. So the number of white flowers, first of all, number of white flowers will be Q square, right? So you can write as Q square will be 18 divided by the total. What is the total here? 8 plus 2, 10. 4 plus 1, 5 plus 1, 6. So 160. So this will be giving you, yeah, this will be giving you the value of the Q square. So what is the value of the Q square? 18 by 160, what it is? Can you do and tell me? 18 by 160. I don't have calculator with me. That's why I'm telling you. Okay, 89. What is 9 by 80? 0. 9.1125. Never. It will be 0.1125. Yeah. 0.1125. Okay, fine. This is q square. So what will be q? Root of 0.1125. Can you tell me the answer of q? If q square is this, what will be q? No, not needed. You can just write it as 0.1125. That is enough. Okay. Don't think about the like a vague things that is going to happen here. Nothing will happen. Okay, even if you are rounding off or you are not rounding off also, no problem at all. Can you tell me what is the root of this? If so, you find actually we will not be rounding it off. What will happen if you are rounding it off? You will be supposed to write as 0.113. Not needed actually. Not needed. So let me calculate as you are not telling the answer. I don't have the calculator with me. That's why I'm asking you to solve. Square root of 0.1125. Yeah, that will be 0.3354, like that you are getting. I'm just rounding it off. I'm just writing it 0.335. Okay, this is the value of q which I got. So what will be the value of p? P plus q is equal to 1, you know. So what will be p? 1 minus q. That is minus 1. 0.6645, or you can write as 0.664. 6 is 5, you write, rounding off. Okay, so this will be the value of P and Q. Do you understand? Do you understand? Now moving to what is the frequency of the heterozygous plants in the field? Yeah, heterozygous alleles they are asking about. Okay. Heterozygous alleles means what it will be? That will be the capital P, small p they are asking about. This is the heterozygous allele. That will be our 2pq. Right. So 2 into 0.335 into, this was our q, 0.665. This was our p. So what you will get if you are multiplying this? 2 into 0.335 into 0.665. So you'll be getting 0.4455, like that it will go. So you can write it as 0.4456 or 445. Anyway, this in this range you will be getting the answer. Okay. No need to round it off. You can just write it as 0.445 or 0.446. Fine. Then moving to the last part. What was the last question? Hold on. Fine. Yeah, tell me. Ask me. What is your problem? Any doubts? If you are speaking, actually, it will be better. Because otherwise, it will be taking some time. Any doubts still here? If you are doing the approximation, what happens is that you will be making, you will not be getting one if you are adding all together. Okay, fine, fine, fine. Take your own time. After that, you tell me, okay. You just write it as, no need to round off. You just write it as the numbers only. Otherwise, you will not be getting the correct answers when you are adding it. You will not be getting one. After writing, tell me. Okay, completed. Okay, you are ready now. And what is the last question? Last question is asking us to check whether p square plus 2pq plus q square you are getting 1. Okay. Anyway, you will be getting 1. If you want to, you should do all these things. 0.665 the whole square plus 2 into pq was 0.665 into 0.335 plus q square 0.335 the whole square. So if you are adding this, will you get 1? That is the question. Okay, you add this and check please whether you are getting 1. They're asking us just to check.